So I am playing with the BLE2 click, and I have that as hardware, and I have this Microbus X-Brain Pro adapter, and the kit I have is the ATtiny 817. I'm going to show you how to get this all running really quickly in MCC&START. So if I create a new project, you can search for BLE, and note that START has quite a number of things supported with BLE. So if I go, there's a wireless connectivity click, and I can type 817, and that's the kit I have. Create new project. So the click is created. We can see that it has a dependency here of a UART asynchronous driver. And the click itself, what we're going to do is click on the user guide there. And so this is a module, RN402 module, integrates RF baseband controller. So here are some different important links. The BLE2 click page, which is this one here. We can go to the product page as well. And here we can see fully certified Bluetooth 4.1 low energy module. So we won't go into that here, but note that there's also a user guide and a data sheet. The user guide has some more example projects in chapter 3, and note that there's a mobile app on Google Play, and there's a link to this here, and we're going to be using that to get the app running. So in these click user guides, we have an example pinout for the Microbus and the X-Brain Pro. So if you have a different kit, then you will just find the relevant X-Brain Pro schematic for that kit, and you'll be able to then match that up with the X-Brain header and fill out the rest of the table here. So I have the 817. I'm just going to use these pins. So note the CN pin is PA6. The wake pin is PB7. And finally, the command pin is PB1. Okay, and we can see the dependency, the UART asynchronous. We want to generate an example. Just check the UART asynchronous. I'm kind of jumping ahead here, but the example itself that we're going to generate includes sets up the module, device information service, as well as the battery service, viewed both as Bluetooth Smart Discover mobile app. We'll show you how that works now. The device information service used to identify the device, battery used to monitor battery associated with the application. Spartans is the default name, and will be changed in that file. So the interface settings, this is of the module itself. So we'll have to set up the UART like that. So the UART configure as interface settings as above. Ensure the printf support is selected. So here we need 115200. The rest of the settings, printf is selected, and there's not much more we need to do. We set up the click itself. If we're interested, we can see the pinouts of our microcontroller, the default clock settings, 3.3 megahertz, but we can just export the project and work now in MCC Studio 7. But notice there are other IDEs supported, like IR for AVR, and Kyle is also available there for SAM devices as well. So I'm just going to drag this across. The default project name is selected, is the name of my zip file. And now I'm in MCC Studio, and I'll just look in the in the examples folder, under source. There will always be a click example, and this battery status underscore example is what we're going to use. We call it from the while one in main, and because we're pulling a file from the click example.h, we need to include the click example.h, well, .c, we need to include the .h file in main. And notice, if I just check the code here, that the beginning of this example actually checks for initialization. That's why we can run it again and again in the while loop. And here, these are the messages just checking the battery status, the battery level. We're going to show what that looks like. Okay, just click on a kit, select a programmer, EDBG, on the kit, and start with our debugging. So that programs the board. So now I'm going to start my mobile app. You can see that Spartans comes up, and what I'm going to do in the click example is just quickly change the name here to BLE2 Trondheim, because that's where I'm sitting in Norway. Program the board again. Stop, scan again. You can see the name changes, and I can go in and connect, and now I can see device information and also the battery service battery level. I can read the battery level, and it's at 1363.33. So what it's doing is showing the hex values there, and if I see this application, I can see 63, 33, 23, and depending on when I read it, we get the different value. Anyway, so that's the click working pretty quickly.